The Royal Hall of Industries was built in 1913 and is located in Moore Park. The venue has been utilised since then for many things, including roller skating arena, a morgue, ice skating rink, ballroom, a venue, and boxing fights. In historical fashion, the hall has been proposed to transform into a current state-of-the-art facility for state and national sporting teams, while being home to a multi-purpose function hall for private and public events. The space will not only provide a multi-million-dollar facility, but it will also include spaces for the community and public access with a cafe and museum. When looking at high indicators of sustainable urban design, we can use the Belago principles to compare with the Royal Hall of Industries upgrades. Obviously, from this upgrade, you can see there's a clear vision for the development, incorporating sustainability and clear growth goals to increase the productivity and efficiency to the Moore Park area. The Royal Hall upgrades will give life to a multi-purpose indoor space, including a top-of-the-line gym, first-class medical facilities, and an international netball court. Additionally, the multi-million-dollar facility will offer spaces for the community and public access. The sustainability components include introducing skylights to bring natural light into the building, replanting trees around the area, using synthetic grass to reduce maintenance and operation costs. The Royal Hall upgrades will be holistic in nature, offering a first-class space for the Sydney Swans and New South Wales Swifts, while also accommodating for junior and women's Swans programs and teams, while creating a community and recreational area with the ability to hold 15,000 people for events, and also offer sports programs and school programs with the Swans and initiatives which can help promote this. Along with this, the upgrades have identified transport to Moore Park, which include regular buses, close proximity to Central Station, a new light rail set to open in 2019 running from Circular Quay to Randwick, and also 2,000 spot car park open from 6am to 2pm, 2am, including 2 hours of free parking. Also, with respects to the landscape, upgrades will include upgrades to bike and pedestrian access to increase more access to the area and promote greater initiative and inclusion around it.
The upgrades proposed for the renovation of the Royal Hall of Industries provide a high level of sustainability, both economically, socially, and environmentally. The new development will include a multi-purpose field which implements an indoor AstroTurf surface. AstroTurf is a relatively new technology which will significantly reduce the operational costs of the development in the long term. Although a high initial cost is observed with AstroTurf's use, the long-term benefit is in its minimal operational and maintenance costs. This will ultimately allow financial resources to be better allocated into other areas of the development in completion. A use of large skylights will also act as a natural light source, reducing the need for artificial light within the facility, directly reducing energy costs, which are one of the largest expenditures associated with building management. Where natural light sources will not suffice, lighting requirements, timers and motion sensors will be installed in tandem to mitigate the use of artificial light used when certain areas are not in use. Pollution and wastage from construction and demolition are significant factors of consideration that developers must incorporate into design and construction. Due to the embodied energy created by forming construction materials, the activity as a whole remains as a significant contributor of energy through wastage from structure demolition and new material use. Due to the facade and building structure remaining the same in the Royal Hall, the intrinsic and heritage value of the building is remained and has a low wastage criteria. In a similar fashion, the building follows this trend of low level of embodied energy consumption through the use of exposed ceiling construction. This allows for the sporting arenas, hallways, and open areas to absorb the building heat produced internally from events. With this, the heat can rise and exit whilst also absorbing into the building's foundation. The new facilities will increase the social benefit of the Royal Hall and employment opportunities, creating up to 120 to 130 new employment opportunities in the development and the general precinct. Thus, the increase of employment due to the upgrades also will likely increase the overall value of the precinct and the monetary intake from tourism and public visits to the area. A significant portion of the development of the Royal Hall is for private benefit. However, these facilities will also be on offer to the general public by offering function areas and use of the sporting facilities for up to 260 days a year. Additionally, there are spaces allocated for the Go Foundation, an organisation which benefits young Indigenous Australians by fostering sporting commitment in youths. This is a program founded by an ex-Sydney Swans player, and it aims to increase the education levels in young Indigenous people in communities in Sydney. Developing spaces like these will allow for community involvement where the resources would otherwise not be accessible, thus assisting and leading to greater social benefit.
Majority of design aspects of the Royal Hall Industry Project link to environmental aspects. For example, all the specified materials, fittings and equipment. The project is currently designed to use the principles of the Green Building Council of Australia via the Design and As-Built version 1.2 tool in order to drive the sustainability outcomes of the project. The current proposed fitting and fixtures have been chosen to fit the performance requirements from the WELS rating scheme in relation to water efficiency. The proposed items are 5-star taps, 5-star urinals, 5-star toilets, 5-star dishwashers and proposed 3-star shelves, if they are able to meet the requirements of supporting teams. Additionally, the project designer is recommending a rainwater tank to be used for toilet flushing and irrigation methods, which will help in the reduction of water usage. The NABERS rating has also been used by designers to try and maximise energy efficiency through the use of specified plant and equipment in order to maintain electricity and gas consumption targets. A design option that is being investigated is the option to install 240 modules of solar panels on the roof in order to maximise the use of renewable energy. This is currently being proposed by the designers and the feasibility is being confirmed. Also, motion detectors and timing sensors are to be fitted to individual lighting control systems and bathrooms in order to reduce the use of artificial light. Plant items like the chilled water system and heating hot water system have been specified by the relevant engineers in order to maximise ongoing energy efficiency. The air conditioning system has been designed from calculations in order to lower energy use, but also maximise the service provided. For example, to make sure the netball court and gym is well ventilated. Management plans like the traffic and pedestrian reduction plans are extremely important in reducing the pedestrian cluster to the Moore Park area. To reduce damage and pollution to the land and water systems around the venue, decreasing the traffic and pedestrian cluster through public transports will help reduce air pollution and damages to the land. The currently designed landscaping for this project includes the removal of 17 trees, although a third party reviewed and confirmed that this would have no impact on the ecological sustainability of the area. A consultant confirmed that the removal of this flora would have no impact on the habitation of surrounding fauna. Although, the project designers have designed for the 17 trees to be replaced with shrubs and grasses within the area in order to improve biodiversity. Also, the increase in design green space allows for a reduction in solar reflection from dark surfaces, positively contributing to the cooling of the area.
Throughout the research conducted, there are a number of potential and current issues identified regarding the building's refurbishment. These include a large amount of glass skylight roofing, which will enable the natural light to raise the temperature of the building, ultimately resulting in an increased cost of air conditioning. The increase of work and pedestrians with the new facility will lead to increasing energy costs as a result of temperature increase and air pollution. This may also lead to a decrease in value of the neighbouring properties. The refurbishment will also require the removal of 7 trees across the whole site. Finally, this is an expensive refurbishment, being a combined total of $65 million for both the design and the refurbishment, which the state government has helped fund by contributing $20 million. The building will also be expensive to operate and maintain, hence why there has been $15 million set aside for future operation and maintenance costs. In response to these issues, we recommend the refurbishment include adjustable louvers to replace the majority, if not all, of the glass skylight roofing. This will allow members to adjust the temperature of the building by either opening or closing the louvers, allowing for increased airflow or reduced sunlight when need be. The introduction of the louvers will help counteract the cost of air conditioning for the facility. The removal of 7 major trees is of public concern. Therefore, it is recommended that the refurbishment plant a minimum of 7 new trees across the entire site. With the cost of maintaining and operating the facility being so high, it is important that the design includes self-maintaining elements into the refurbishment that will assist in reducing this cost. It is clear that this has already been identified and included throughout the design. For example, the use of AstroTurf throughout the facility as opposed to normal grass completely eliminates the cost involved with maintaining a normal grass field. However, it is recommended that the design is given a re-evaluation in order to determine whether there are any potential replacements that will also help reduce this cost.